Okay, it's part 2 of lexicographically sum, lexicographically smallest equivalent string, and you can see I'm stuck with this because there is more complex connections here. Like, for example, I cannot my code cannot pick up replacement of S to A, because see here, E can be replaced with R, then E can be replaced with O, then O can be replaced with A. That means that E can be replaced with A, and my algorithm is not picking it up. So and I checked, asked ChatGPT what is the best to give me a hint, and it said that it also said in hint here, model these equalities as edges of graph. Each connected component of the graph assigned each node to component to lowest lexicographical chart. Finally converting, and this is the topic of union find. So probably it could be solved by union find, and we have to rewrite the whole thing with the union find algorithm. So how union algorithm can be applied here? So we obviously have we add all connections, right? How union find can be applied here?
Union find can be applied here by following these steps. 1. Initialization. Create a union find structure where each character is initially its own parent. 2. Union operation. For each pair of equivalent characters, perform a union operation to connect their sets. This ensures that all characters in the same equivalence group are linked. 3. Find operation. Use the find operation to determine the root or representative of each character's set. The root will represent the smallest lexicographical character in the group. 4. Building the result. For each character in the original string, replace it with the smallest character, the root, from its equivalence group to form the lexicographically smallest string. This approach efficiently groups characters and helps build the desired output.
Okay, so let's follow these instructions, and first we have to define default values when every parent is parent of itself, and then we will have to find we have to find the result structure, right? We have to find elements. So union find let's check this answer again. Create union find structure which should its own parent. Union operation for each character perform union operation to connect their side. This ensures character building the result. Okay, building results is easy. So we define two operation union which accept x and y, and we define find which accept x. Can you explain union operation in more details?
Certainly. Here's how the union operation works in the context of union find. 1. Purpose. The union operation merges two sets represented by their roots. It ensures that elements considered equivalent are part of the same set. 2. Find roots. When performing a union on two elements, first determine the roots of each element using the find operation. 3. Merge sets. Link one root to the other. Typically, you attach the smaller root to the larger root to maintain balance, which helps keep the structure efficient. 4. Path compression. During the find operation, apply path compression by making nodes point directly to their root. This optimizes future operations by flattening the structure. 5. Implementation. The union operation generally updates the parent of one root to be the other, effectively merging the two sets. This approach keeps the union find structure efficient, allowing quick unions and finds.
Okay, so we find the root x and the root y, then we have to compare, in our case, if root x more than root of y, what we're gonna do, we're gonna assign p root y equal root x, else vice versa. Now find is first we have to assign default. So we set default for x as x. Then if x not equal, then x and x equal find right, and we return parent x. Hey, can you explain find operation in more details?
Sure. Here's a detailed explanation of the find operation in union find. 1. Purpose. The find operation determines the root or representative of the set to which an element belongs. This helps identify if two elements are in the same set. 2. Recursive search. The operation recursively follows parent pointers from the element to the root. The root is the element that points to itself. 3. Path compression. During the find operation, path compression is applied. This means updating each node's parent to point directly to the root. This step significantly speeds up future operations by flattening the tree structure. 4. Efficiency. With path compression, the find operation becomes very efficient, nearly constant time in practice, even for large data sets. By consistently applying path compression, the union find structure remains optimal for repeated union and find operations.
Okay, so we basically have a default with setting with flattening structure pointing directly to parent, and we return parent when we found it. So the final step of our algorithm, we for in range, we just go to base to range base str, and we assign our result value to it, and we add or we append what we can find with we doing base string, right? Base string. So we can base string I, and we have to return string, so we'll join yes. Okay, let's give it a try. Append, yes, append. Oh, we didn't yeah, so we didn't do union. So we have to do for in range. We didn't call. So we have a procedures, but we didn't call them. And this is why find is always returning the same. So in range length of S1, what we're gonna do, we're gonna call reunion, and between S1I and S2I, and this should work. But it's not. If X, oh, we have to do this. Yep. Okay. Okay, that's it. We solved it with union find. Yeah, basically that's it. Thank you for watching.